All right. For this session, it's going to be, I'm going to talk about some of the Elixir concepts. It's not going to be Elixir 101. I'm not going to go through some of the basic syntax. So instead, what I would like to do is to show you some of the concepts that are pretty cool or fairly different than what we normally know in the wonderful land of OOP, like what we do in PHP or in Swift or in Kotlin. So, and instead of me sort of talking through code examples or things that I, especially prepare for this talk, I thought I'll actually dig through some of the libraries, as you can see, real Elixir libraries, and then use snippets from those real-world Elixir libraries to actually walk through some of the concepts. So first library is the world's best naive Bayes library, and a few things I would like to talk about. Well, this is the library. The first concept, structs. Now, many languages actually have structs. I can't remember whether PHP does. Probably not. So structs is to hold data, right? Data structure. But in Elixir, Elixir being a compile language, it does a bunch of things at compile time rather than on runtime. So structs, the data, I guess the fields are actually guaranteed during compile time. So when you compile, if the uses of the structs are different than the definition of the struct itself, then it'll actually generate a compile time error. So you'll know before you actually run your application that things have gone wrong, then you go ahead and fix them before you even run your code. So that's structs, how you define them. And here's just a very basic example of how you actually I guess, call a struct or instantiate a struct with data. The next concept is module attributes. Again, module attributes are actually checked during compile time as well. Here's another example. So a lot of times we actually use module attributes to store like application-wide configuration. So configuration, the vast majority of the configuration items are not going to be evaluated per runtime. So if we don't need to change them during runtime, we can actually put them as module attributes, and they get compiled, they get checked at compile time instead. There are a lot of special reserved words. They appear as module attributes. So in this case, callback. This is a reserved special case. There are a few others, which I'll get to, but these reserved or special cases are actually language specific. So in Elixir, they mean very different things. Here's a, I guess, follow on from the previous slide. Previous slide, we have callback. Here we have behavior, and these two actually work hand in hand. So these are actually for defining specific behaviors for a particular module. I'm not going to go down to the details of what behavior is, but just knowing that there are special cases that you can use module attributes for. Here is another example of a module attribute. At doc, this is actually a module attribute as well, even though it's highlighted differently because it's actually documentation. So again, this is a special case. And what's cool about doc is that here it's just some random words, right? It's arbitrary. You can put anything in it. Here's like a title of examples. But here, this bit here, IEX, these are code examples, right? Hopefully you recognize this is, code examples. This is how you run this particular function. And this is the return value for that particular function. Now, what's cool about this is that in Elixir, we have a concept called Doctest. which if you've done Python before, you'll know that this is a concept whereby in your comment, you can actually put code examples that would actually get run against the language. So when we run the test suite, the test will actually run the code. And if I change something here, if I change the return value, the test suite will actually break. So that's a very cool thing. Here's how to run the Doctest. Essentially, you have a test file, and all you need is use the Doctest keyword and put in the module name, and that's it. So it's a very cool concept. It's one of my favorite things about Elixir, like is Doctest. And I've actually written a blog post about that, because I think having Doctest in Elixir a lot of times changes the way I think about how to structure my code and how to design my application, because a lot of times, you know, whether it's in PHP, Ruby, any kind of language, it's very easy for you to create, let's say, a private function that does something because you want to encapsulate the logic, right? And it's very easy for you to have a huge class with many functions because of that. Now, in Elixir, Doctest only runs on private functions. It doesn't, sorry, only runs on public functions. It doesn't apply to private functions. So whenever you have a private function that you want to encapsulate certain piece of logic, and if that piece of logic is isolated enough that it can be tested on its own on a unit level, then it's time to extract it out into a module so that you can actually have a public interface that you can use Doctest for. So Doctest actually almost like forces you to think about composition, because you know, in other languages, there's nothing will stop you from just keep creating private methods. In Elixir, Doctest is the tool to actually help you, I guess, mold the shape of your application. Speaking of composition, another thing is function delegation. Some languages, such as Ruby, will have like a library that will allow you to do that. In Ruby, it's called a forwarder. In Elixir, it's built into the language. It delegates certain public functions into another module. And optionally, you can also customize the name of the receiving function as well. Now, what's useful about this, again, it comes back to composition, right? You try to encapsulate certain logic into a public interface, but that public function itself can contain many smaller pieces of logic that put together will enable you to do one thing. So in this case, instead of creating a bunch of private functions that allow you to do that, move them to a separate module. And then, you know, depending on the interface for that module, then you can use Doctest as well. I guess here's just an example of the equivalent. Like instead of using function delegate, you can also just like call the actual function within the function as well. So basically this is what def delegate does. One thing that's very cool, I guess, the first time you see like how Elixir code looks like is the pipe operator, which is what this bit here is. What it does is actually really simple. All it does is it takes what's previously the return value of the previous line or the previous evaluation, put it into, or pass it as the first argument into the function here. So in this case, what we have for the second line is token parser.parse, the first argument being hit, and then this is actually the second argument and third argument. That's all it does, right? But what it allows us to do is to actually specify your logic in the flow, in the sequential flow. And that's really useful because it's very easy to see what's actually going on in your code. Instead of having like, you know, assign the return value of the first function to a variable and pass the variable in, or if you want to sort of use indentation and then have things like be embedded within each other. Like you can achieve the same thing in different kind of ways, but in Elixir, this is a very kind of, I guess, easy to follow or easy to visualize way to know exactly the steps that will allow certain functionality to work. So that's actually a really, really cool thing that Elixir has. Now, Elixir is a functional language, which I guess I haven't actually talked about. Elixir is a functional language, which means that there are only pure functions. What you pass in will guarantee the outcome for most cases. But we know in applications, we need to keep states or we need to change states somehow, right? So how do we actually do that in Elixir? Well, in Elixir, we have a concept called agent. Agent is specifically designed to manage your application state. What it does is actually start a new agent, which in Elixir, what that means is that it would actually spin up a new process, a new Elixir process. And that process will have a PID. That's how you will actually keep track of the agent itself. And then within the agent, you can do whatever you like to it. So basically, you can have essentially an anonymous function that contain any kind of logic, which will contain your state. And that state will get kept in that PID. So the next time, if you want to grab the state, all you need is to remember the PID, and then you can actually fetch your state. So here's an example of fetching the state by essentially remembering and getting the PID. Now here's another example of using agent, because a lot of times you have a PID already, you want to make an update. So instead of calling like get and then somehow update it, there's a I guess like a shortcut function, get and update, and then you do your thing and return the PID in the new state, and that will actually update the agent itself. So that's basically how we manage states in Elixir in a nutshell by using agents. The second library is the world's best queuing library in Elixir. And what's cool about this queuing library is that, well, first of all, that's called one pool queue. OPQ is the name of the library. It's actually being used by us. So it's being used by Ironbank, and it's being used by Golden Gateway thanks to Eddie. So in Ironbank, the queuing library is responsible for queuing up all the scheduled payments as well as the emails that we sent out. In Golden Gateway, what do we use in Golden Gateway for? Events. Event bus. So Golden Gateway's event bus is powered by the queuing system. Anyway, so we talk about agents for managing states by spinning up new processes. Task is something similar in its nature. So what it does is also spinning up a bunch of Elixir processes. However, tasks are actually asynchronous by its nature. So when you want to parallelize your work, or if you want to, I guess, perform work in a more concurrent fashion, where you can use tasks for that. So that's how Elixir, I guess, perform concurrent work a lot of times by using task. Now, one very fundamental concept of Elixir is pattern matching. This is only one form of pattern matching. I'll sort of get to the other forms of pattern matching a bit later. This is pattern matching on the function level. So process item is a function. In this case, it's a private function, but it's a function. But you can see that we have like 3 separate definitions of process item. And the reason for that is because what we pass in as arguments are different, or they can be different. And here is where the language will use pattern match to actually match. So the The first example is actually a tuple with 3 elements. So when you call this function, if you pass in a tuple with 3 elements, the first line will get matched. However, you can also pass in, let's say, a tuple with 2 elements, or you can pass in a string, you can pass in anything, then it will try to match against the second line. And in this case, if we pass in an anonymous function into the function or into process item, then the second line will get matched, because here's what we call a guard in Elixir to say that only match this if item is a function. For all other cases, it'll go to the third line. So if you pass in a string, it'll match the third line, and then it'll just return the string back to you. So that's pattern matching in Elixir in the form of function pattern matching for function arguments.
This is the beginning lesson.
Huh? Yeah. Now, something very cool in Elixir, which was actually introduced quite recently, I think 2 years ago or so, I think, is called GenStage. What GenStage does is it's exchange events with back pressure. I'll explain what that is in a second. But this is like how you would use GenStage. If you remember the syntax for like using agents or using tasks, they all do like start link. Start link is, I guess, a function to actually start the association between a child process that you're about to spin up with the main process, which is the process that you're currently working in. So that's how you spin up GenStages. So in the context of a queuing system, why do we actually need GenStage? Because back pressure, what that means is that the consumer, so on one end, you have a producer, on the other end, you have consumer. Actually, I'll show you the graph. On this side, there's consumer, on this side is producer, right? Typically, in a traditional, I guess, form, the producer is responsible for producing things for the consumer to consume, right? That's how APIs work. You produce stuff and then you take stuff that the producer produces. It's still the case for GenStage. The only difference being consumers are the ones making what we call demands. What does that mean? So let's say in the database, there are like 1,000 different items that the consumers will sort of fetch, maybe one by one or a couple items at a time. But consumers have an appetite, right? It's like depending on your database system, depending on internet connection, depending on various sort of variables, you might not want like 1,000 items at the same time, or you might not be able to process the information or the data fast enough. In that case, how many items the producer produces during each stage is dependent on the consumer's appetite. So consumer, in this case, is determining how many items actually gets flowed into this pipeline at any given moment. So that's what GenStage is for. It's for controlling the flow of the data or the rate of the, anyway. Now, there's a lower level concept called GenServer. So it has a similar name, GenServer. It doesn't really mean anything, it's generic server, but GenServer is a very fundamental concept in Elixir. What it does is for implementing any kind of client server kind of communication. So anytime you want to, I guess, send data across processes, or even some of the higher level concepts like agents and tasks, internally, they all gen servers. So it's a lower level implementation that allow you to do any kind of client server relation. One thing I forgot to mention is that a gen server can do cast or call what these things are, imagining, you know, in the TCP/IP, like you have TCP, you have UDP. So call is more like TCP, where you get a handshake, you get response back. Cast it's just like, hey, here's some information, do whatever. So it's more like UDP. You don't necessarily need to hear back. And this is how, I guess, you implement a Gen server. So these are all kind of predefined names for how you would define what gets called in cast and in call. So that's how you would define a Gen server. Something even lower level is a process. Something I only touched on briefly is Elixir is a highly concurrent language. So spinning up processes, or in this case, Elixir processes, is actually very cheap in terms of the computing resource. So this is something very different to what you would do, I guess, in Java, for instance. Like when you spin up a Java thread, it's relatively expensive. So you can spin up maybe hundreds of or thousands of Java threads. Here, you can actually spin up millions of processes on a single computer. So it has nothing to do with the system or operating system level process. It's a very lightweight threading system that Elixir has. And there's like APIs to actually manipulate those processes as well. And processes in Elixir can be distributed because you can actually spin up Erlang clusters. And then once you have the clusters running across different, let's say if we run a Erlang cluster across multiple EC2s on AWS, processes, you can actually send information across the distributed network. So it's not limited to just a single computer. Something that's cool as well is a concept called observer. And this is something that you don't usually get in a sort of programming language that's geared more towards web use cases. What it does is that this is how you would actually start an observer. This is actually an Erlang thing. It's not specific to Elixir. So a lot of times we use colon and the name to actually call into Erlang modules. So in this case, we're calling an Erlang module called observer. And this is actually what the observer looks like. It's actually a GUI application. So there are a lot of different information that you can actually get from the observer, like the system, like how much RAM the system has, the CPU, memory allocators. And what's cool is also in the application, let's say crawler, these are the pits, like, you know, when I talked about agents before, they have pits. These are pits like individual Elixir processes. So you can see exactly which process is actually live in memory right now as you observe your application. And there's a bunch of other things like a list of all the processes in memory and things like that. So that's very cool for debugging, and it's very cool to see like a load chart will have like a graph chart as well. The final library is the crawler library that Matt started using for his personal project as well. So that's the library. One thing I'm also very, I guess it's a very cool concept is there's a keyword in Elixir. It's a language keyword called with. What that does is to control the flow of your logic. And this is also done via pattern matching. So this is another form of pattern matching. What you see here is this is the with keyword, right? And on separate lines, these are the steps. But you can achieve steps by just, you know, assigning variables and what have you, right? However, what with does is that the pattern match comes with this key, I guess the symbol here, is it actually evaluates the right-hand side, get the return value, and have the return value match against the left-hand side. What that does is that, let's say the very first line, it'll always match, almost always, unless it throws an exception, because it's a variable, right? It can match anything. But the second line, it's a tuple of two elements. The first element has to be a symbol of OK. What that means is that the second line will get matched, and if the return value is anything other than in the form of a two-element tuple with the first element being a symbol, then it won't actually get matched. If the second line doesn't get matched, the rest of the pattern match will get ignored, and it'll, in this case, nothing will get returned, or it'll return nil, because there's no else. Otherwise, it'll basically do it line by line to make sure the return values of each line match against the left-hand side. So this is how we control flow, and we use that very extensively throughout our code bases here at Explore as well. And this is another example with an else statement or an else block. So we check things against, again, two element tuples. In this case, we don't actually care about the first element. I guess I forgot to mention, like in Elixir, we have another special case variable called underscore. It's a variable, but it matches basically anything. So what that means is basically, we don't care about what the first element is. It can be a string, can be anything. We only care about the second element being true. If it's not that, it'll actually come down here to evaluate the else block. But in this case, it'll actually be another pattern match. So we only match, I guess, the first, it'll return a tuple of two elements. The first element will assign it to a file type variable. And then we return something else instead. But it's a very cool way to control the flow. And this is something, as far as I'm aware, is pretty unique to Elixir. I haven't seen that in any other languages that I've kind of looked into. So this is something very cool. At times, it can significantly reduce the amount of, I guess, overhead you have in terms of like how to actually control a flow of your function. And again, pattern match. So what this does is that whatever the return value is from store.init will get pattern matched against this tuple here. Now, something that is also interesting that people don't often realize early on when we look at Elixir source code is that, let's focus on the second line here. What does that look like? It looks like, assigning the right-hand side to a variable in a lot of languages, right? In PHP, whatever language, that's what it usually means. In Elixir, it's not assignment. In Elixir, actually, there's no concept of assigning things to a variable. This is also a pattern match. So this is actually the equal sign is not an assignment operator. It's actually a pattern match operator. What that does is that take that return value, match against left-hand side. The left-hand side so happens to be a variable which can match anything. Therefore, this variable now becomes the return value of that. So it's a pattern match instead of assignment. Again, Gen server, which I briefly touched on before, but I haven't talked about how you would implement a Gen server. Very simple. Use Gen server. Use is a keyword of Elixir. It basically grabs a lot of stuff from the Gen server module, and then you have to implement its interface. So here's an example of implementing the cast side of things. So as a convention, usually we try to keep the modules very small. What that means is that this is one module. However, this is the client side of the implementation. This is the server side of the implementation. So the client side actually calls genserver.cast to initiate the, I guess, the logic. Here's the flip side on the server side to handle what that actually does. So that's how we implement a gen server. Something also cool in Elixir, which is also somewhat new, that got introduced in the last year or two, is a concept called registry. Think of that like as like memcached or like even Redis. This is basically something built into the language itself that we can use to essentially do key value store. And it's distributed as well. If we have an Erlang cluster, it runs on the cluster. So basically, it's a replacement for Redis. We don't need Redis when we do Elixir, in theory. So that's pretty cool. We don't need a third-party library to do that. It's built into the language. Now, Elixir is a dynamically typed language. So there's no compile time type checking per se. However, we do have a concept called type spec. What type spec does is that it actually does allow you to define types for things, right? So in this case, there's a type URL, which is a string. So if it's not a string, the compiler will complain. However, this is actually not built into the Elixir language itself. There's a, I guess, second-party library that allows compile time checking to check against whether your variables and whatnot have the correct type. But it does type checking. It's very different from statically typed languages. It doesn't do a bunch of things, but at least it's there. So what I personally find useful is if I have something like in a context of a library or an application, if I have a defined interface, so to speak, and other developers will need to implement that interface, that's where type checking comes in handy, because that allows you to ensure the new interfaces will adhere to the type. So they can't actually, assign any arbitrary kind of types into your interface. And because of type spec, I remember a year or two ago, I believe, last year, I was playing around, I think, in crawler, and then I started noticing that every time I run the type checking, it fails. But I've double-checked, triple-checked my library. It's all fine. It turns out it was a bug in Elixir. So if you have Elixir on your computer, my code is on your computer. So just put it out there. There are more concepts that for one reason or another I haven't really used in those libraries, but nonetheless, I think they're pretty cool concepts that we should know about. One is called protocols, which in PHP and Swift they call interfaces. In Kotlin, sorry, the other way around. In Swift it's called protocols. In Kotlin it's called interfaces. It allows for polymorphism. So polymorphism is also possible in Elixir. Macros. Macros is actually something that Elixir as a community kind of discouraged you to use, because they actually, it's for metaprogramming, which is, use your code to write code. It's being discouraged because a lot of Elixir, the Elixir community was born out of the Ruby community. In Ruby community, we're the opposite. We're on the way other extreme end of metaprogramming. Like we use metaprogramming for almost everything. Like we write like custom DSLs all the time. But the advantage of metaprogramming is that you have your own DSL. It's very cool. It actually saves a lot of time and makes your application interface very simple. On the flip side is that it hides the complexity as well. So a lot of, when you see like a new DSL, you'll be like, wow, that's cool, but how does it actually work? Why does it work? And then you have to dig through your definitions of those metaprogramming things to find out how they were defined. We use macros in some of our systems. So it does have its advantage. But I guess the advice being like, think twice about using a macro. If you can simply use a module to achieve the same thing, it's probably preferable. And finally, this is a most recent new concept introduced to Elixir, and it's actually not part of the language itself, but it's done by the same team. So consider it a first-party library. So it's called Flow. What it does, it's to parallelize the computing of a collection of things, a collection of data, and it does it via gen stages. So basically, it basically treats a collection of items and use gen stages to actually process them. So that's a very cool thing to achieve things such as streaming or any time where you need to deal, let's say, with external data where the data can be infinite or it can be a huge size of a collection. You use Flow to process them. So you can control the flow and then you can parallelize them at the same time. So that's a very cool concept. I haven't actually used it that much myself, but I know if I can, I will, because it's pretty cool. And that's how you sort of make your application highly concurrent. I believe that's it. Thanks.